potential difference across A and B. Right. To find AB potential difference, we need to apply potential divider method. Right. So potential difference across AB, let's keep adding, and then finally we can distribute the potentials accordingly. Right. So one thing we need to know, when resistors are parallel with each other, we add them 1 over R. Say the resistance is R1 and R2, the equivalent will be 1 over R equals 1 over R1 plus 1 over R2. And if these two are in series one after the other, R1 R2, then R equals R1 plus R2. You should know that. Right. Now in this, let's get into the question now. Then these two resistors we can directly add. You can see the current goes along this surface, and certain amount will go along this surface, and certain amount along this surface again. So initially we can conclude these resistors we cannot directly get whether these are series or parallel, but 15 ohms and 5 ohms you can see one after the other, same current flows to them, so we can add them as series resistors. So 15 plus 5, that is 20 ohms, right? 20 ohms. So we can conclude we have 20 ohms that is parallel to this 20 ohms. So when adding 1 over 20 plus 1 over 20, these two are parallel, you can see that equals 1 over, we get 20 common denominator 2. So when taking the reciprocal, we get 10 ohms. That means, yes, when we add these two, we get 10 ohms, right? So you can see here we have 10 ohms, and again 20 plus 10, yes, 10 ohms. This 10 and this 10, yes, these two are again series, so 10 plus 10, 20. That means we have across here 20 ohms, right? Now this 20 ohms and 10 ohms, yes, these two are parallel. So 1 over 10 plus 1 over 20 again equals 1 over R. Common denominator is 20. So 1 plus 2, you can see 20 over 3 is the resistance between these 2 points. Now we can easily, yes, share 10 ohms and 20 over 3, yes, this 500 ohms. Say now we have 500 ohms, 500 volt, and we have 20 over 3 resistance and 10 ohms resistor. Let's apply resistance ratio method. So resistance ratio is equal to potential ratio. So here we can take 10 is to 2 over 3. That means 30 is to 20, 3 is to 2 ratio. So we need only the potential difference across these two. So applying the ratio 2, 3 is to 2 ratio, 2 over 5 fraction, 3 over 5 fraction. We need only the potential, these potential difference. So 2 over 5 into, yes, 500, we get 200 volt. That means this potential difference is 200 volt. Then that is distributed with this ohms, this 10 ohms, and yes, between the C and D points we have not 20, we have, yes, 10 ohms. So 10 is to 10, yes, 1 is to 1 ratio. So we get, yes, 1 is to 1 ratio, half and half, 200 is distributed, then we get 100 volt, right? Then, yes, we have 100 volt between this 15 ohms and 5 ohms. Now we are getting closer to the answer. 15 is to 5 ratio, 3 is to 1. Yes, we need the fractional value for 1/4, 3/4. So then us to find the potential difference AB, 1/4. So 1/4 into 100, we get 25 volt. That's our final answer, AB, 25 volt. Right. I hope you have tried the question and hopefully you have got the answer. If you couldn't get the answer, try similar type of questions and practice as much as possible. And if you think this is valuable, yes, share it with your friends, study together, and win together.